Last homework page, homework 40. I'm still going to be dealing with limits, but before we go back to talking about limits, we are going to determine points of discontinuity from a graph. A graph is continuous if you can keep your pencil on it and go from one end of the graph to the other end of the graph without picking up your pencil. So if I started here and I ran my pencil along here, in order to get to the next part of my graph, I have to jump up here. I have to lift my pencil up off the paper. And so at this point, my graph is discontinuous. Then I'd go from here to here. Again, to get to the next part of my line, I've got to jump here. So here my graph is discontinuous. Here again, I'd have to go from here to here. I've got a hole again, so it's discontinuous. And then it goes down to the end of my graph. So on this one, I have 3 points of discontinuity. I'm looking at the x values of the point. So at -3, at -1, and at +1 are my points where my graph is discontinuous. So basically they're telling you your graph is continuous if you can go from one end to the other without picking up your pen at all. But if I have to pick up my pen to get to the next part of my graph, oh, there's a break in my graph. It's discontinuous. So number 2, whoops. Again, I have my function. I'm looking at my graph between the interval of -4 and 4. I'm looking for points where my graph is discontinuous. So here I'm going along my graph, but in order to get to here, I would have to jump off of there. So here is a point where I'm discontinuous. I'm going to start here. I'm going to go down here, oops, to go up here. Again, I have a break in my graph, so I have a point that's discontinuous. So on this one, I only have 2 spots where I'm discontinuous, at -2 and at +2. So -2 and 2 would be my 2 points where my graph is discontinuous. So again, if you look at that number 3, if I'm looking for my points where my graph is discontinuous, I can see right here is a spot where I have a hole in my graph, right here, and right here. So at -1, +1, and +3. So in looking at your graph, if it's asking you if it's discontinuous, you're looking for where, if I were tracing my graph, would I have to pick up my pen to go to the next point? Or look for the holes in your graph. There your point is discontinuous. 4, 5, and 6, we're dealing with infinite limits. An infinite limit means that my graph either continues in the negative direction, down, 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 in other words, to negative infinity, or it continues in the positive direction, going up, 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 up. And again, I'm going to find my limit as x approaches a value from the negative direction, meaning it approaches from the left side, or from the positive direction, meaning it approaches from the right side. And it only has a limit if both of those values come up to be the same thing. So I'm going to find the limit of my function as x approaches -2 from the negative direction. In other words, from the left-hand side. So as I approach -2 from the left-hand side, my graph just keeps going down and down and down and down and down. That means it's approaching negative infinity. If I look at my graph as x approaches -2 from the positive direction, in other words, from the right-hand side, my limit right here stops, and I scribbled all over the place, but at -2, right? The y value where I approach would be -2. Now in this case, since my limit from the left-hand side is negative infinity and my limit from the right-hand side is -2, the limit of my function at -2 does not exist. It only exists if both of these came up to the same answer. So if we look at the next one, looking at my graph, as x approaches negative 1, or x approaches 1, excuse me, 1 from the negative direction. So as I approach 1 from my left-hand side, my graph is going up and up and up and up and up, so that means it's approaching positive infinity. If I'm going to approach 1 from my positive direction or my right-hand side, as I'm approaching the value of 1, this graph is going down and down and down and down, so negative infinity. Again, on this one, the limit does not exist because the limit as I approach from the left-hand side and the limit as I approach from the right-hand side are not the same, so the limit does not exist when I do that one. We look at number 6. Here, I am doing my limit as x approaches 2. I'm going to come from the positive direction first. So if I'm coming from the right-hand side, my limit ends up going up and up and up and up, going to infinity. As x approaches 2 from the negative direction or the left-hand side, again, I'm going up and up and up and up, positive infinity. So the limit on this graph as x approaches 2 is going to be at infinity because from both sides they end up going up to positive infinity, and since they're both the same, then a limit does exist. It's at infinity. Seven, 8, and 9 are going to be giving you limits as x approaches negative infinity or positive infinity. So as your graph goes either way to the left or way to the right, do I have a limit? So on this one, as x approaches negative infinity, I'm starting here and I'm keeping going up and down, up and down, up and down, and it's still always going to go up and down. It's not going to stop and level off at one number, nor is it going to continue to go way up or way down. So in this case, there is not a limit as I go towards the negative direction. If I do my limit as I approach infinity, so I'm starting here and I'm going and going and going, again it just keeps going up and down, up and down, up and down. It's not going to level off to the same number. It's not going to keep going down. It's not going to keep going up. So in this case again, the limit does not exist. It just keeps going on and on and on forever, up, down, up, down, up, down. It never levels off. Number 8, I am looking at my function as x approaches negative infinity. So as I approach negative infinity, now this graph levels off and it approaches negative 3. Here, as x approaches positive infinity, I'm going and I keep going this way, this way, this way, this way. Again, you can see the graph levels off. And again on this one, it levels off at negative 3. And so, if I look at this one, they don't ask for the limit of either of them. They're just having you do what is the limit as I go from negative infinity and what's the limit as I go to positive infinity. Happens to be that they both ended up being negative 3. And number 9. I'm finding the limit of my function as x approaches negative infinity. So as I go this way on my graph, notice it's just going to keep going up, 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 or at least we have to assume that. So it's going to go up to positive infinity. Here, as x approaches infinity, so as I go to the right, I'm going to keep going down, 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 down. So the limit on that side going to be negative infinity. So, x approaching negative infinity means I'm going to the left. X approaches positive infinity, I'm going to the right. And does it either level off, does it keep going up, does it keep going down, or does my pattern just keep repeating and I don't have a limit? All right, 10, 11, and 12, we are doing limits at infinity again. So as x approaches infinity, we want to find the limit. So they've got a few rules for us to follow if I have a rational function. In other words, I have a fraction. So if the degree of the top, is less than of the bottom, the degree of the top is less than the degree of the bottom, then the limit equals 0. If the degree of the top equals the bottom, the degree of the top is equal to the degree of the bottom, then you're going to have the ratio of the leading coefficients. We'll get to that. And if the degree of the top is greater than the degree of the bottom, that's our third case, then I'm going to either have positive infinity or negative infinity for my limit. And I have to figure out which one it's going to be. So, those are my rules as x approaches infinity if I have a rational function, which is a fraction. So here, the degree of the top is 1. The degree of the bottom is 2. 1 is less than 2. So the degree of the top is less than the degree of the bottom. Well, that makes it really easy. The limit as x approaches infinity is just going to be 0. Hey, I'm done. That was an easy one to do. Wish they all were that way. If we look at part B, the degree of the top is 3. The degree of the bottom is 2. So the degree of the top is greater than the degree of the bottom. By the way, they're assuming you remember how to find the degree of your polynomial. The degree is the degree of the highest term. So a constant term has a degree of 0. This has a degree of 1. So it's a linear one. It's a degree of 1. Here my highest exponent is a 2. So it has a degree of 2. So here my highest exponent is 3. Here it's a 2. 3 is greater than 2. So it tells me the degree of the top is greater than the degree of the bottom. So I know my answer is either going to be positive infinity or negative infinity. So what I need to do is figure out the sign of my answer as I approach, in this case, negative infinity. Now, if I'm going to approach negative infinity, I want a big negative number. I'm just going to say I'm going to use negative 1,000. That's probably big enough. You probably don't want to use negative 1 or negative 2. It's kind of small, but we're going to use negative 1,000. I'm going to plug that in to see if I'm going to get a positive answer or a negative answer, which tells me if I'm going to go to positive infinity or negative infinity. So negative 7 minus 4 times negative 1,000 cubed over negative 7 minus 2 times negative 1,000 squared. Now, I'm just worried about the sign. I'm really not even worried about my numbers. So if I take negative 1,000 and I cube it, that's going to stay negative. Nope, I better work it out, because otherwise I have to figure out my number. I'm just going to use my calculator. So on the top, I was going to take a shortcut, but that's not going to work very well. So I'm just going to punch the top in. Negative 7 minus 4 parentheses, negative 1,000, 1, 2, 3, cubed. Gives me 3,999,999,993. It's a positive number. On the bottom, negative 7 minus 2 parentheses, negative 1,000 squared gives me negative 2,000,007. Now, I have a positive over a negative, and since I have a positive over a negative, I'm going to get a negative. And in this case then, since I know that it's going to approach infinity, I'm going to say, okay, I'm approaching negative infinity. So you really don't care what the number answer is. You're just checking to see what the sign of the answer is. Is it going to approach a negative number or a positive number? You can see I'm going to have a really big negative number, so I'm going to approach negative infinity. All right, so if I look at the next one, I'm finding the limit as x approaches negative infinity. The degree of the top is 1. The degree of the bottom is also 1. So the degree of the top equals the degree of the bottom. So that means it's going to be the ratio of the leading coefficients. The leading coefficients are the coefficients of the number in front of your highest exponent term. So in this case, this would be my leading coefficient of 7. This would be the leading coefficient, the negative 5. And so I'm just going to have negative 7/5 for my limit. If I put that in best form, I'd have 7x plus 1, negative 5x minus 6. There's my leading coefficients. They're both out in front of my expression. So if the degree of the top is the same as the degree of the bottom, my limit is going to be the ratio of their leading coefficients. This one, the degree of the top is 3, the degree of the bottom is 2. There's one of those that I have to check. 3 is greater than 2. So I know my limit is going to be either positive infinity or negative infinity. I'm checking as x approaches positive infinity. So again, I'm going to use 1,000. I'm going to use a positive number. On the previous one, we were doing negative infinity, so I use negative 1,000. So I'm going to take 5 times 1,000 cubed plus 1, and then negative 6 minus 7 times 1,000 squared. So 5 times 1,000 to the third plus 1 gives me 5,000,000,000,001. On the bottom, negative 6 minus 7 times 1,000 squared gives me negative 7,000,006. So again, I have a positive over a negative. A positive over a negative is a negative, and so it's going to approach negative infinity. My number is just going to get smaller and smaller and smaller and smaller. The bigger the number I use, the smaller my answer would get, the more negative it would be. Number 12, I'm checking my limit as x approaches negative infinity. This time the degree of the top is 2, the degree of the bottom is 1. So the degree of the top is greater than the degree of the bottom. So if the degree of the top is greater than the degree of the bottom, again, this is one I have to check. I'm approaching negative infinity, so I'm going to use negative 1,000 again. So if it's negative, I use a negative number. If it was positive, I'd use a positive number. And you want to use a fairly big number. So I picked 1,000. So I'm going to do 2 times negative 1,000 squared plus 3, and 4 times negative 1,000 minus 3. So 2 times negative 1,000 squared plus 3 gives me 2,000,003. It's a positive number. On the bottom, 4 times negative 1,000 minus 3. It's a negative number, 4,003. A positive divided by a negative is a negative, and so I know that it's going to approach negative infinity as x approaches negative infinity. My graph is also going to approach negative infinity. And the last one here, the degree of the top is 2, the degree of the bottom is 3, the degree of the top is less than the degree of the bottom. If the degree of the top is less than the degree of the bottom, the limit is just 0. So again, if my top is less than my bottom for the degree, my limit equals 0. If the top equals the bottom, you have the ratio of the leading coefficients. And if the top is greater than the bottom, either going to get negative infinity or positive infinity, and you're just going to substitute in a really big number or a really small number and check to see what is the sign of your answer. That's going to tell you if you're at a positive infinity or a negative infinity. All right, 13, 14, and 15. The last ones on here are ones where if you do the test, as x approaches 3, I would get a number over 0. And division by 0 is undefined. If it's not 0 over 0 and you have a number over 0, you're either going to get plus or minus infinity when you plug those in. So in this case, it's the same kind of thing that we did on those previous ones. I'm going to put numbers in where I approach that value, and I want to see, do I have a positive answer or a negative answer? So I know if I have a positive infinity or a negative infinity for my limit. So we are saying x approaches 3 from the left-hand side. Now you don't want to go down too far from that, and so if I take a little bit off of 3, I am going to use 2.9. Don't want to round it down too far, but you don't want to have too many decimals to have to deal with. I suppose on Alex I'll probably use 2.99999 or some crazy thing, but 2.9 should probably work. So what I'm going to do is I'm going to do 1 over 2.9 minus 3 squared. Again, I'm really not concerned about the answer, I'm concerned about the sign of my answer. So I'm going to have 1 over, if I take 2.9 minus 3, I get negative 0.1, but when I square that, I get a positive 0.01. So I get a positive over a positive, which means I'm going to get a positive, and so infinity is going to be the limit on this one as x approaches 3 from the left-hand side. Here, as x approaches 3 from the right-hand side, I just want a little bit bigger than 3. So 3.1 is what I'm going to plug in. So I'm going to have 1 over 3.1 minus 3 squared. So 3.1 minus 3 again would be 0.1. When I square my 0.1, I'm going to have 0.01. So again, I'm going to have a positive over a positive. And so as this one approaches 3, it's going to approach positive infinity. In other words, just infinity. So since the limit as I approach from the left-hand side is the same as the limit as I approach from the right-hand side, the limit of my function is going to be the same thing. The limit as I approach from the left was infinity. The limit as I approach from the right was infinity. So the limit of the whole function is also infinity. So this happens when you try to evaluate directly and you have a number over 0. Part B, if I move that down so I can see part B. Again, if I would put 2 in here, I would get 3 over 0. So I know my limit's either going to be positive infinity or negative infinity. So as I approach 2 from the left-hand side, I'm going to use 1.9. So I'm going to have 3 over 2 minus, not negative 1.9, 1.9. So I'm going to get 3 over 2 minus 1.9 would be 0.1, 0.1. So again, I'm not concerned about the numerical answer. I'm concerned about the sign of my answer. I'm going to have a positive over a positive, which means I have a positive. I'm going to approach positive infinity as I come from the left-hand side. Right-hand side, I'm just a little bigger than 2, so I'm going to use 2.1. So I'm going to have 3 over 2 minus 2.1. So I'm going to have 3 over a negative 0.1. I have a positive on top and a negative on the bottom. A positive over a negative is a negative, which means as I approach from the right-hand side, I'm going to be going to negative infinity. Well, since my limit as I approach from the left is positive infinity, but my limit as I approach from the right is negative infinity, the limit as I approach 2 does not exist because they don't approach the same value. So number 14, as I look at this one, I'm doing the limit as x approaches 3. Again, if I would put a 3 in there, 3 minus 1 is 2, but 3 minus 3 is 0, I would get 2 over 0. Since I have a number over 0, I know I'm either going to get infinity or negative infinity. So, as x approaches 3 from the left-hand side, I'm going to use 2.9. So 2.9 minus 1 over 2.9 minus 3. 2.9 minus 1 is 1.9. 2.9 minus 3 is negative 0.1. I have a positive over a negative, which is going to be negative, and so the limit is going to be at negative infinity. As x approaches 3 from the right-hand side, just a little bigger than 3, I'm going to use 3.1. So 3.1 minus 1 over 3.1 minus 3. So this is going to give me 2.1. This is going to give me a positive 0.1. So I'm going to have a positive over a positive, which is a positive. So my limit here is going to be infinity. So as I approach from the left-hand side, my limit was negative infinity. As I approach from the right-hand side, it's positive infinity, since those two things are not the same. As I approach 3, the limit does not exist. Part B on number 14. I am doing the limit of my expression, again, as x approaches 3. So if I would put 3 in here, 3 squared is 9, 9 times 4 is 36. But on the bottom, 3 minus 3 is 0, 0 squared is 0, so again I get a number over 0. Anytime I get a number over 0 when I evaluate directly, I know my limit is either positive infinity or negative infinity. So as I approach 3 from the negative direction, a little smaller than 3 would be 2.9. So I'm going to do 4 times 2.9 squared over 2.9 minus 3 squared. 4 times 2.9 squared is 33.64. 2.9 minus 3 is negative 0.1, but when I square that, I get positive 0.01. So I get a positive over a positive, which means I have a positive. So positive infinity is going to be my limit as I approach from the left-hand side of 3. As x approaches 3 from the positive direction, or from the right-hand side, just a little bigger than 3 would be 3.1. So 4 times 3.1 squared over 3.1 minus 3. Let's erase that whole thing. 3.1 minus 3 squared. So 4 times 3.1 squared. Again, really the number's not important, so if you know by looking at that, that's going to stay positive, more power to you. I'm just going to put the number there, but it's a positive number. Same thing on the bottom. 3.1 minus 3 would be 0.1, and when you square that, it's going to stay positive. It happens to be 0.01, not that that's important. I'm going to have a positive over a positive, which means I have positive infinity for my limit. So, as I approach from the left-hand side, my limit was positive infinity. As I approach from the right-hand side, my limit is positive infinity. That means my limit does exist. If I could write, it would be positive infinity. One more, actually 2 more, but one question with 2 parts. So on my next one, if I'm doing the limit as x approaches 3, I would have 5 over 3 squared is 9, 9 minus 9 is 0. So again, I get 5 over 0. I know that my limit's going to be either positive infinity or negative infinity because I have a number over 0 and not 0 over 0. So as I approach 3 from the left-hand side, again, I'm going to use 2.9. So 5 over 2.9 squared minus 9. Well, the top's going to stay 5. 2.9 squared minus 9 gives me negative 0.59. I have a positive over a negative, so negative infinity is what that's going to approach. As I approach 3 from the positive direction, so just a little bigger than 3, I'm going to use 3.1. So 5 over 3.1 squared minus 9. 5 on top. 3.1 squared minus 9 gives me 0.61. So I have a positive over a positive, which means positive infinity. So in this one, as I approach from the left, I got negative infinity. As I approach from the right, I get positive infinity. Since those are different, the limit does not exist. And one last one here. This one we are doing the limit as x approaches 5. 4 minus 5 would be negative 1. 5 minus 5 would be 0. Again, I have a number over 0, so I know my limit is either going to be positive infinity or negative infinity. So as I approach 5 from the negative direction, just a little bit smaller than 5, I'm going to use 4.9. So 4 minus 4.9 over 5 minus 4.9. This is going to give me negative 0.9. Just checking, yep. 5 minus 4.9 would be positive 0.1. So I get a negative over a positive, which is going to be negative infinity then, as x approaches from the left-hand side. As x approaches 5 from the right-hand side. So from the positive direction, just a little bit bigger, I'm going to plug in 5.1. So 4 minus 5.1 over 5 minus 5.1. 4 minus 5.1 would give me, whoa, I put divided by. 4 minus 5.1 would give me negative 1.1. 5 minus 5.1 would give me negative 0.1. I have a negative over a negative. A negative over a negative is a positive, so I'm going to get positive infinity. So my limit as x approaches 5 from the left is negative infinity. My limit as x approaches 5 from the right is positive infinity. Since those are different, the limit as x approaches 5 does not exist. So 13, 14, and 15, the point where if I evaluate directly and I get a number over 0, and since division by 0 is undefined, it tells me that I'm either going to have a limit of positive infinity or negative infinity. So I want to use numbers very, very close to what I have so that I can see what the sign is, so I know if I'm going to have negative infinity or positive infinity.